Okay, finishing up with problem number 3 for MAC1105, section 2.5. We had just finished in the last video getting all of these new points where we took all the x's and multiplied by -1 and added 1 to the y values, and that's what the results that you see here. I went ahead and graphed all these points for you. And basically what you're seeing in this new graph after I plotted all these points is that when the x value got multiplied by -1, I've already typed that out for you in this comment box. It took the original graph and it spun it across the y-axis. That's what multiplying the x value by -1 does. When the -1 is out here, it flips it upside down. But when it's in front of the x, it flips the graph across the y-axis, which is what I put right here. So that's in blue. Moving on to number 4. I don't think there's anything much different there. Okay, I don't think I'm going to do that one because it's just so repetitive of numbers 1, 2, and 3. But the problem that you're seeing here has something a little bit different. You haven't had one of these yet. That's called a horizontal shifter. And I'll do number 6 as well because that one's a little juicier. It's got several different things going on in one problem. So this you haven't had yet. Anytime you are adding or subtracting to your x value, again, any kind of operations, anything that are going to change the x position of the graph, the numbers will be with the x inside a parenthesis. And if they're not, they are things that are acting upon the y value, as keep repeating, probably driving you crazy in numbers 1, 2, and 3. This is what we refer to as a horizontal shift. Whenever there is a number in the equation that says either addition on the x or subtraction on the x, before you actually act upon the horizontal shift, I mean for purposes of the graph, you need to remember to switch the sign. Okay, this is only for a horizontal shift, which are identified again as either numbers that are added or subtracted from the x value. You must switch the sign before actually, if you're going to be acting upon them appropriately in the graph. Okay, so your x values, notice that although there's a +2 in the equation, the way I'm acting upon the x is to subtract 2. So this is my horizontal shift. Because it has now switched to -2, that means the x values in the original graph, and this is a piecewise graph, there's 2 pieces, those x values are going to move 2 units to the left because it ended up being negative. So all your x coordinates are now going to be 2 units to the left. You'll see that when I go to plot it anyway. Then the -1 multiplier that you see out here, because it is not inside here with the x's, that means it's an action upon your y values. So I wrote that for you here, just in a little bit of a different way. Here it's in function notation. Here I'm just writing it with respect to what are you doing to each of the coordinates. Now, because this graph comes in 2 pieces, I'm going to keep this organized for you. We'll do the leftmost piece first. Notice that the leftmost piece, as well as the right piece, has a colored end, a solid endpoint, and an open endpoint. So first I'm going to do the solid endpoint, listing it right from the graph, which is -4, 0. Those are the coordinates on that solid endpoint. And then the open endpoint, we got an open endpoint and a solid endpoint. So when I translate these points, do the actions that are going to move the point around, I will make this one solid just like the point it came from. I'll make this one open just like the point it came from. That open point is identified as 0, 2. Okay, the actions I'm taking upon them, I'm subtracting 2 from my x value. So this take away 2, -6, 0 take away 2, -2, and then the action on my y's is to multiply the y's by -1. So 0 times -1, 0. 2 times -1, -2. Don't forget, this will be solid. This will be open, just like the original points they came from. Then I'll also do my rightmost piece, which is this one right here, which also has a solid endpoint and an open endpoint. Let's do the solid one first. Those go with 0, 0. And the open endpoint is 4, 2. Then performing the actions that you've been asked to do in this problem, subtracting 2 from your x value. So 0 take away 2, -2. 4 take away 2, just regular 2 or positive 2. And then multiplying the y values by -1. Here's your original y values on the rightmost piece. 0 times -1, 0. 2 times -1, -2. And you're going to see in this particular problem that although it said +2 in the original, it really switched to a -2, as all horizontal shifts must be treated that way, where you switch the sign. You have to remember to do that. So you're going to see this moving 2 units to the left, as I discussed, and it's also, because the negative's out here, not inside with the x, it flips it across the x-axis. So if they're up here, now they're going to be down here. And you'll see that when I graph. Okay, here we go, graphing those new points. The new points are the ones where we acted upon the original points using these actions. That would be this and this. That'll be my leftmost point. So I'm going to go -6, 0 and make it a solid point. I'm going to go -2, -2 and make it an open point. And I'm going to connect them. Notice that this goes down, whereas the original point this came from goes up. That's considered a flip. Okay, then going to the rightmost point where I am graphing this as well as this. These are the points that have the actions performed on them as stated right here, and I acted on these points. Okay, I'm going to make this one solid, -2, 0. That'll be right there. And then I'm going to do 2, -2. So +2, -2. I'm going to make that one open and connect. And that's my new graph. Okay, that one just happened to be a piecewise function. Now moving to problem number 6, you're going to notice that there are several operations. Well, there's just more involved here, but it's really just a whole bunch of the same thing. So let's do that one. Again, this is a piecewise function. You have the piece further to the left, and then you have the piece over on the right. And I'll keep it organized for you like I did for the last one. I'll do the leftmost piece first. The points on the original graph are -5, 0. They have it listed for you. And that is a solid point. So I'll make sure that even when I do my actions upon the point, that I will make it solid when I go to graph it. First, let's just list the points like we always do. And then the other point that goes with that same segment over here on the left is 0, -6. Okay, then acting upon the point, there are several things that you're going to do. It's going to flip over. It's going to flip over with respect to a horizontal line. So if these are going down, the ones that you're going to create after you translate and do all the algebraic operations that you need to do, they're going to be going up. These are going down. Yours are going to be going up. That would be considered flipping over the x-axis, where it's down here and then it flips up here. This 1/3 is just going to make the graph wider, because any multiplier that's less than 1 makes the graph wider. Let's see, this is a horizontal shift. So you're going to flip over, and I might have written all these comments right here. Yep, flips over the x-axis. Vertical shift of 3 units down. That's your vertical shift right there. And then that horizontal shift, Even though, again, I'm going to keep saying this, even though it says positive 2, you're really going to use a negative 2 on your x's because you are required for all horizontal shifting to switch the sign before actually using it to act upon the x and the y coordinates. Only the horizontal shifts do that. Okay, so doing all these things. Now, since the easiest thing is what we're doing to the x's, and that's because we're only doing one thing. Whereas the y's, we, again, let me point this out. Whole point of the section is that when the number's inside here with the x's, you do it to the x's. When the numbers are not on the inside the parenthesis with the x, it's stuff that you do to the y. They are operations that you perform on the y. So we're going to be multiplying our y's by negative 1/3, just as it says here. And we're also going to be subtracting 3 from our y's, again, because this number is not inside here. Therefore, it's an operation on y. And that's what it says here. You'll do the multiplication first and then subtract because that's order of operations. That multiplication comes before subtraction. Okay, I'll do the x's first. They're easier. So negative 5 take away 2, negative 7. 0 take away 2, negative 2. Then you can scratch out the work for the y if you need to. If you do it in your head, fine. But it's negative 1/3 times that original y value. And then you're going to subtract 3. So my original y value was 0. So that's easy because 0 times any number is just 0. 0 take away 3, negative 3. So your brand new y value after carrying out these two actions is negative 3. Likewise, I'm going to do the same two actions, multiplying by 1/3 on that y value and then subtracting 3. My y value here was negative 6. That's really not too bad. Negative 6 is the same thing as negative 6 over 1. And when you're multiplying two fractions, it's top times top, bottom times bottom. And then, of course, there's that minus 3 there. This 6 over 3 that you see is really a 2. 2 take away 3, negative 1. So that's the new partner right there. So in that manner, you can do the, as much or as little work as you need to. Just, your skill set will tell you how much you need to actually put on the paper, but you should always show work to some degree. So I can see that you are actually thinking about that rather than getting it from the calculator. Just like I did in the last problem, that was a piecewise function, only it had less things to do to it. You also have a segment on the right, and you're doing the same thing. You're taking the points, recognizing that one of them is solid, and that point is 0, 0. And then one of them is open, and that point is 5, negative 6. And you're doing the operations that you did here. Those operations were subtract 2 from the x's. Okay, so I'm going to have to just do this down here. The point that goes with this will be 0 take away 2, negative 2. And then when you do the y's, remember you are plugging in that y value and then you're multiplying it by negative 1/3 and then subtracting 3. Just like this plan says here. Take the y value, multiply by negative 1/3, and then subtract 3. Now I've already done it for 0. Here was the work right here. Because this happened to have the same y value as what you're doing right now. So I can just use that answer right there. Okay, and then if I want to get my values that go with this one, the open-ended circle, again, for the x's, you're subtracting 2. So 5 take away 2, 3. For the y's, you're going the y value times negative 1/3, subtract 3. Again, look at what we did here. For this segment that was over on the left, wasn't the y value negative 6, just like the one that I'm working on now? So, of course, you're going to get the same answer. So just helping you to cut down on the work. Okay, so you are going to be plotting this brand new point where you've performed all actions required by this problem, subtracting 2 on the x's and multiplying the y's by -1/3, then subtracting 3, which resulted in this and this point. This one will be